You can just feel it, can't you?
Yeah.
The energy building across, well, pretty much every developer community right now. People are moving past just, the simple chatbots. They're looking at real autonomous agent AI tools. They don't just want text generation anymore. They want systems that can plan, use tools, adapt when things go wrong, and actually ship work. In the
Yeah.
real world, the interest is just, it's huge. But look, if you've actually tried to start building one of these things, you probably know it feels a bit like driving on a freeway with absolutely no signs up. It can be, well, overwhelming. So that's what we're doing today. We've taken some of the best structured guides out there on Agentic AI, and we're doing this deep dive to basically give you that clear map. This is the path that hopefully respects your time, giving you the mental models, the architecture insights you need to get from just being curious to actually building something useful.
Exactly. That's the mission for us today. We're going to cut through a lot of the high-level talk and really zero in on the structured takeaways. We're talking about the tables, the scorecards, the architectural comparisons from the best guides we found. Things that give you immediate, actionable comparison points. For choosing tools, figuring out if they're actually working, and importantly, how to think about governance before you launch anything. And to really get started, you need this fundamental lens. It sort of defines the whole field right now. Agent systems. They basically grow from two different family trees, two lineages. First, you've got the symbolic or classical side. This is where agents use explicit rules, logic, deterministic steps. Think flowcharts, if-then statements. Everything is, well, auditable.
Right, the predictable path. You can trace exactly why it did what it did.
Exactly. And then you have the big modern wave, the neural or generative lineage. And here, the agency, the decision-making, it emerges pretty much entirely from prompt-driven orchestration. The large language model, the LLM, acts like a central manager.
Okay, so the LLM is the boss, deciding what to do next, which tool to call.
Precisely. It relies on learned behavior, patterns it picked up during training, and sometimes, frankly, stochastic or slightly random decision-making. And keeping those two paradigms, symbolic versus neural distinct, in your mind is just absolutely essential as we go through this. Every choice you make about tools, design, risk assessment, it flows directly from which lineage your agent uses, or, as we'll see, how you decide to mix them.
Okay, right. Let's unpack that then. Starting with that first big decision, picking your stack. When you look at all these autonomous agent tools, you've got to look past the cool names, right? The real question is, what's the actual orchestration mechanism? What's under the hood that gets you from A to B with the least amount of, well, hassle?
Exactly. And the source material we looked at really highlights this shift. Modern frameworks. They're generally not using those older classical planning loops like, say, BDI, which needed really rigid pre-programmed steps. No, they're using the LLM itself as the coordinator, the executive brain. And that orchestration method is the key difference you see laid out in Table 1, the Agentic AI Tools Frameworks Overview. It really captures this.
Okay, Table 1. Let's walk through some key comparisons based on that table, focusing on the intent, the architecture. Maybe start with the more sort of linear approach, LangChain.
Right. LangChain's primary mechanism is prompt chaining. It's designed for creating sequences, often linear, of calls to the model and various tools.
Though good for workflows.
Very effective for that. It's controllable, and its typical fit is exactly that. Multi-step workflow automation. Think generating reports, controlled data tasks, things that follow a sequence.
Okay, but then things get more complex pretty fast, right? You start hearing about agents working in teams.
You do. And that's where frameworks like AutoGen and CrewAI come in.
Yeah.
They are leaders in this multi-agent space, but they tackle the team concept quite differently, which is important.
How so? What's the difference there?
Well, AutoGen really focuses on multi-agent conversation. It sort of simulates an internal debate or maybe a brainstorming session among different agent personas.
So they talk back and forth until they solve it.
Kind of, yeah. They exchange responses, refine ideas until they reach some kind of conclusion or complete the task. It's quite dynamic.
Okay, and CrewAI.
CrewAI leans more towards structured, role-based workflows. You explicitly define roles like senior market analyst or lead strategist, along with their specific goals and tools. The system uses these defined roles to structure the collaboration, making it maybe a bit more predictable and less prone to just, endless chat loops.
So the typical fit for both AutoGen and CrewAI, because they're team-based, it's for more complex stuff.
Absolutely. Think complex collaborative problem solving, deep market analysis, maybe generating and reviewing code, comprehensive research projects where you genuinely need multiple perspectives or specialized skills interacting.
Got it. Then there are frameworks maybe more geared towards like enterprise integration or knowledge work.
Right. Semantic Kernel is a good example there. It places a really heavy emphasis on composing plugins or functions, which it calls skills. If your main goal is tight integration with existing, maybe large corporate code bases, or turning a user's vague intent into a series of precise executable actions or skills, Semantic Kernel is architected with that kind of precision in mind.
Okay. And the last big one often mentioned, LlamaIndex. Where does that fit?
LlamaIndex is really centered on the knowledge retrieval aspect. Its core strength is retrieval augmented generation, RAG. It excels at managing data connectors, building indexes over your information, and pulling external knowledge stuff outside the LLM's training data into the agent's context.
So ideal for research agents.
Exactly. If you're building an agent that needs to query internal documents, databases, or specific domain knowledge that the base model wouldn't know, LlamaIndex is purpose-built for that retrieval and grounding task.
So the immediate takeaway here, looking at table 1, it seems like you need to match the framework's architecture to the problem's complexity.
That's the heart of it. If you need reliable, structured production for somewhat linear tasks, maybe LangChain, LlamaIndex, Semantic Kernel, or even CrewAI's role-based structure could work well. But if your problem truly demands that kind of emergent, collaborative intelligence from multiple viewpoints, then the neural multi-agent orchestration you see in AutoGen, or the structured team approach of CrewAI that represents the current state-of-the-art for those complex systems.
Okay, this is super helpful for choosing a starting point. But here's where I think things get really interesting, maybe even a bit tricky. Once you've picked a tool, how do you actually know if it's, working well? Not just spitting out text, but working. We need to separate the hype from the substance here.
Yes, and this is absolutely critical. This is why the source materials emphasize using something like Table 3, the Agentic AI Tools Evaluation Scorecard. This isn't just theoretical. This is what experienced teams genuinely use when they decide whether to commit real resources, real budget to a particular stack. It forces you to move beyond just, did it produce text? And think critically about metrics that actually predict success in a production environment.
Table 3, the scorecard. Okay, let's break down those criteria. The source highlights 5 essential ones. What's it first?
Setup speed.
Setup speed. Why is that so high on the list? Seems almost basic.
Because momentum is incredibly fragile in these projects. Setup speed measures the real time it takes from, say, cloning the repository to getting your first successful run, even a simple one. If it takes your team 3 weeks just wrestling with dependencies, configuring connectors, getting API keys sorted, your feedback loop is way too slow. You're burning valuable time and budget before you've even learned anything. Fast setup builds traction, allows quick iteration.
Okay, that makes sense. Faster learning cycles. What's next on the scorecard?
Tooling fit.
Right, seems obvious, doesn't work with the tools you need, but what are we actually measuring?
It's about the maturity and native support for the connectors. Your agent is only as good as the APIs and data sources it can reliably talk to. So you measure tooling fit by looking at the number of well-supported native tools or how robust those existing connectors are. If you find yourself spending 80% of your development time writing custom wrappers for standard APIs that the framework should handle out of the box, you've got a poor tooling fit.
Yeah, that definitely eats up time. Okay, the third one sounds huge. Observability.
It is huge. You absolutely cannot improve or even safely operate what you can't see, especially when you have an LLM potentially making unexpected stochastic decisions in the driver's seat.
So this isn't just about logging hello world.
No, not at all. This is about financial risk, operational risk, mission drift. Good observability means having clear run logs, yes, but also detailed traces showing the decision path, cost tracking per run or per token, usage reports for different tools or APIs. Think about it. If your agent gets stuck in an unexpected loop or starts hammering a very expensive third-party API, you need immediate visibility to stop it before you rack up thousands of dollars in cloud bills or API fees literally overnight. Poor observability. That's the #1 cause of bill shock in early agent projects.
Wow, okay. Definitely critical. The fourth metric, reliability. This feels like the core goal, right? The agent has to actually meet the goal, not just generate plausible-sounding text. But how do you measure that, especially when the output can be dynamic or creative?
You need a structured evaluation process. Reliability isn't just a feeling. It's measured against a defined test set where you have clear ground truth or expected outcomes, maybe even a required output schema. The success rate quantifies how often the agent achieves the full, correct outcome, meeting all constraints, versus just producing some kind of response. If your target is, say, 95% reliability for a specific task, You need the observability and evaluation tools in place to actually measure and prove you're hitting that number.
Right, proof, not just hope. And the final one on the scorecard.
Governance fit. This is often what separates a serious enterprise-ready stack from a cool research experiment. The framework's built-in capabilities for oversight, control, and auditing must match the risk profile of the tasks you're automating.
So things like policy gates, audit logs, approval steps.
Exactly. Can you enforce rules? Can you require human review before certain actions?
Yeah.
Can you easily trace who or what did what when? That's governance fit.
And the sources we looked at connect the scorecard directly to a really practical one-week plan for getting started. It seems like that plan forces you to think about these metrics right away.
It does, deliberately. For example, day 4 of that plan is specifically about adding schema-locked outputs to your agent.
Why is schema locking so important for reliability in production?
Because without it, you get noise and inconsistency. Let's say your agent is supposed to output JSON data to feed into another system or API. If, alongside the valid JSON, it decides to add a friendly introductory sentence like, sure, here's the data you requested, that downstream system will likely break. Schema locking forces the agent's output to conform strictly to the required structure, preventing those kinds of errors.
Okay, so it enforces predictability.
Precisely. And then by day 7, the plan has you running a full pilot test and explicitly measuring cost per outcome and the success rate. So you're hitting observability, cost, and reliability success rate metrics immediately. You're not just building code, you're measuring against that evaluation scorecard from the very first week. It builds in that discipline.
That makes sense. So building agents that actually touch real systems, real data, it means you absolutely have to design for reality. And reality includes failures, security issues, maybe regulatory constraints. You mentioned governance fit. This whole governance layer, it's not just something you bolt on at the end, is it? It sounds like it needs to be baked into the architecture from the start.
It absolutely does. And that brings us right back to that fundamental split we started with, symbolic versus neural. Because their governance challenges and how you mitigate them are completely different. If we look at Table 2 in the source material, the Agentic AI tool's governance matrix, it lays this out very clearly. It aligns the oversight challenges directly with the underlying mechanics, symbolic or neural.
Okay, Table 2, the governance matrix. Let's dig into that. What's a key difference? Maybe start with the accountability challenge. What happens when something goes wrong?
Okay. For symbolic systems, failures are usually, well, relatively straightforward to diagnose. If it messes up, you can typically trace the error back to a specific logic bug in the code, or maybe a missing rule for an edge case you didn't anticipate.
So the fix is coding.
Essentially, yes. Mitigation involves standard software engineering practices, code verification, testing, maybe even formal methods or proofs for highly critical systems. The cause is usually traceable in the explicit logic.
Right, but with neural systems, it's a whole different ballgame, isn't it? Failures there aren't usually neat logic bugs.
Not typically. Failures in neural agents often arise from the inherent randomness, the stochastic nature of the LLM's output. Or they come from prompt injection attacks, where someone tricks the LLM, or maybe from biases baked into the model's training data. The root cause is often much harder to pinpoint because the mechanism itself is opaque.
So how on earth do you mitigate failures when you can't always see the direct cause like you can in code?
Mitigation for neural systems becomes about building layers of defense around the core model. You need things like robust prompt shields filters trying to detect and block malicious inputs. You might use output filtering or validation, maybe watermarking outputs where possible. And absolutely critical is having comprehensive audit trails that log everything. The prompt, the context provided, the agent's reasoning steps if you can get them, the final output, the tools called.
Yeah.
You can't rely on proving the logic correct, so you have to rely on these defensive measures and detailed logging.
Okay, that makes sense. Layers of defense. This must also dramatically impact explainability, right? Being able to understand why the agent did something.
Massively. In the symbolic world, explainability is inherently high. The steps are explicit, they're auditable. It's like following that flowchart we mentioned. You can see the path it took.
But for neural agents?
For neural agents, explainability is often low to maybe moderate at best. The agent's behavior emerges from these complex, opaque internal states within the neural network. It's very hard, sometimes impossible, to say definitively why it chose one path over another.
So how do you deal with that lack of transparency, especially in fields like finance or healthcare where you need to explain decisions?
Well, you mitigate the opacity. You log absolutely every piece of context the agent was given, the prompt, the retrieved data, the conversation history. You also try to enforce reasoning traces. This means designing the prompts or the system to require the agent to explicitly output its step-by-step thought process or rationale before it takes a significant action.
Yeah.
It doesn't make the underlying neural process transparent, but it gives the human supervisor a trail to review, something to audit.
Okay, so you get a reported thought process even if the actual mechanism is still a bit black boxy.
Exactly. It's a practical workaround.
And this difference must profoundly change how human oversight works, too. How should we supervise these two fundamentally different types of agents?
The sources use a really helpful analogy here. Think about supervising a symbolic agent like you would a junior programmer.
Okay.
They follow clear instructions, they work based on logic. So you check their code, you review their logic steps, you look for errors in their implementation of the rules. It's code review, essentially.
Makes sense. But supervising a neural agent?
Supervising a neural agent is more like supervising a very talented, maybe brilliant, but fundamentally unpredictable intern.
Aha. Okay, I know that feeling.
Right. They might come up with incredibly creative, insightful solutions that you never would have thought of, but they also might go completely off the rails, misunderstand the context, or do something unexpected without warning because their reasoning isn't based on explicit rules you can easily check.
So for the unpredictable intern agent, your oversight strategy has to be totally different.
Totally different. You're not checking their line-by-line logic because, well, there isn't any in the traditional sense. Instead, you focus on carefully managing their context. What information are you feeding them? You implement strong guardrails, technical limits on what they can do. You use sandboxing safe environments where they can operate without causing real harm if they mess up. And crucially, you often rely on approval gates. Before the agent can commit a critical action, like sending an email to a client, spending money, or changing production code, a human needs to review and approve it. You limit the blast radius of their potential unpredictability.
It sounds like the real cutting edge, then, is trying to get the best of both worlds, the hybrid approach.
That's definitely where a lot of the research momentum is. Combining symbolic reliability, maybe using rules engines for critical policy checks, final validation steps, or enforcing strict constraints with neural adaptability for the fuzzier parts, like initial planning, drafting content, or understanding ambiguous requests.
That sounds powerful. Precision plus flexibility.
It can be very powerful. But the sources offer a strong caution here. If you go down the hybrid path, you immediately inherit both sets of governance complexities. You need the code verification discipline of symbolic systems and the prompt shielding, context management, and observability required for neural systems. The governance of these complex hybrid systems is actually flagged as one of the most underexplored, most challenging areas in the current literature. So if you choose hybrid, you need to plan for that double complexity right from the start.
Okay, wow. So let's try and synthesize this. What does all this mean for you, the builder, listening right now? It feels like the agentic AI era is really defined by this necessary shift towards orchestration. We're leveraging these powerful generative models, not just to, chat, but to actually plan and take actions in the world. And increasingly, the path seems to involve moving beyond single agents to teams of specialized agents working together.
That's a great summary. And your next step, if you want to follow the path laid out by the most successful teams we're seeing, it's actually very concrete and actionable. Pick one simple, genuinely low-risk use case first. The source material often uses an example like a news brief bot. Maybe it just crawls 2 specific websites you trust, summarizes the top stories according to a very strict schema or template, and posts that summary to an internal sandbox channel where it can't do any harm.
Keep it simple, keep it safe initially.
Exactly. Build that prototype, maybe aiming for that 1-week time frame. Use the simplest stack from Table 1 that can realistically achieve the goal.
And critically, measure it. Right from the start, use that evaluation scorecard from Table 3, measure your actual cost per successful news brief generated, and measure your success rate. How often does it produce a perfect schema-compliant summary versus failing or producing junk?
That measurement step is how real teams bridge that gap. They move from just technical curiosity, playing with the tools, to building dependable, understandable, production-ready systems.
So the North Star here seems pretty stable. Useful, reliable systems are the ones that ultimately win and provide value.
That's right. And currently, the most promising architectural path seems to be blending paradigms, using the precision and verifiability of symbolic logic, where you absolutely need guarantees to act as guardrails or validators for the creative, adaptive, but less predictable neural core, getting that balance of precision and resilience.
Thinking about this whole shift towards orchestration, towards blended reliability, what really stands out to you as you watch this field evolve?
For me, it's the explicit focus now on measurement and governance early in the process. It's a sign the field is maturing beyond just demos.
Yeah, moving from can it work to does it work reliably and safely? Okay, let's leave our listeners with a final provocative thought to mull over, building on that governance challenge. Since the literature, as you mentioned, flags that governing these complex symbolic and especially hybrid systems is still pretty underexplored territory, think about this. If your agent had access to genuinely sensitive company data, what specific action would you absolutely gate behind a mandatory, non-negotiable symbolic policy layer or rule check before the agent could execute it? Would it be generating emails externally, committing code to a main branch, executing a financial transaction above a certain threshold? Think about that precise gating action, that hard symbolic check as you start designing your first production agent. Where's that line for you?